Factor each radicand into its prime factors. Simplify each radical expression. So this shows another approach for simplifying radicals using prime factorizations. The square root of 40, so what I'm first going to do is find the prime factorization of 40. Alright, so let's do that side work over here. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So there's my prime factorization. So I now have that the square root of 40 is the square root of 2 cubed times 5. Now, notice I'm going to change this up a little bit. That square root of 2 cubed, well, I know that there's a perfect square in there, 2 times 2, 2 squared. So I'm going to break it up differently. I'm going to write it as 2 squared times 2 times 5. Now, using the product rule for radicals, I'm going to break this up into 2 radicals. The square root of 2 squared times the square root of 10. And the square root of 2 squared is 2, and so that's 2 times the square root of 10. So there's an approach using prime factorizations. Notice all I did there is I used the factorization 4 times 10. Right? So I really said the square root of 4 times the square root of 10. And again, that gives us 2 times the square root of 10. So however you want to think of it. The square root of 700. Well, again, let's do a little side work here. 700 is, I don't know. How about let's use 10 times 70. 10 is 2 times 5. 70 is 7 times 10. And that 10 is 2 times 5. So I have then the square root of 2 squared by 5 squared by 7. And now I'm going to break this up as the square root of 2 squared by the square root of 5 squared by the square root of 7. And so then that's 2 times 5 times the square root of 7, or 10 times the square root of 7. Alternatively, I just use the factorization 100 times 7, noticing that 100 is a perfect square, and then breaking it up and getting the same result.